The Secrets of Orchestration course consists of 3 parts. Part 1, Orchestral Code Voicings. Part 2, Methods of Orchestral Texture Making. Part 3, How to Make Orchestral Effects using different scales and harmony. I prefer to start with lectures on code voicing because it is 50% of orchestration. Part 1, Orchestral Code Voicings. Chapter 1, Woodwinds section. Lecture 1, Introduction to Code Voicing. It is enough to know some basic rules for starting to code voicing. I don't want to bother you with too much information. First, we have to learn the following: notation rules in the score, a range of woodwind instruments, harmonic series, relation of timbres of woodwind instruments, ADSR meaning. The symphony orchestra is divided into 4 sections: strings, woodwinds, brass, and percussion. Each section has own timbres and playing techniques. I will explain all of this step by step. But I prefer to teach playing techniques of instruments in while the orchestration, not before the orchestration. I think this will be more useful and pleasant for students. Let's start. The woodwind section is one of the main sections of an orchestra which consists of 4 different families: flute family, oboe family, clarinet family, and the bassoon family. Each family includes a lot of instruments in itself, but we will learn only the main instruments which come across more in a concert and film music. Flute family, flute and the piccolo. Oboe family, oboe and the English horn. Clarinet family, clarinet and the bass clarinet. Bassoon family, bassoon and the contrabassoon. This is the basic instruments name schedule in 4 different languages which dominate in orchestral scores: English, German, French, and Italian. You don't have to memorize all of them, but having such a list on hand will make it easier for you to analyze orchestral scores. For example, knowing the names of the instruments in French will help you when looking at Ravel's orchestration. In my country, all Azerbaijani composers prefer Italian language, but I will explain in English. Before the orchestration, the composer must set up in the score a list of instruments that he will use. Setup of woodwind section as following: woodwind in pairs, woodwind in threes, woodwind in fours. When woodwinds in pairs, there are 2 flutes, 2 oboes, 2 clarinets, and 2 bassoons played in the orchestra. During the score, the second player of each pair can switch the instrument to the other one. For example, second flute player can play the piccolo. It means player will switch the flute to piccolo. Composer should give time to switch instruments. The same rule applies to other woodwind setup. Depending on the style, the composer can add or remove some of the instruments that he needs. My lectures are based on orchestration of woodwinds in threes, which is most useful for both concert music and film music. When woodwinds in threes, the alignment of the instrument will be as follows: 3 flutes. Third flute player can also play the piccolo. 3 oboes. Third oboe player can also play the English horn. 3 clarinets. Third clarinet player can play the bass clarinet. 3 bassoons. Third bassoon player can play the contrabassoon. Piccolo. The sounding range of this instrument is from D5 to C8. The piccolo is a transposing instrument, which means in the score should written an octave lower than sounding. Notation is written only in treble clef. Flute. The sounding range of this instrument is from B3 to D7. The concert flute in C is a non-transposing instrument and written as sounding. This instrument notated only in treble clef. Oboe. The oboe's sounding range is from B flat 3 to A6. This is a non-transposing instrument and written as sounding. Oboe pass is notated only in treble clef. English horn. The English horn has a sounding range from E3 to B5. This instrument is a transposing instrument and written a perfect fifth higher than sounding. Notation is in only treble clef. Clarinet in B flat. The clarinet in B flat has a sounding range from D3 to B flat 6. Clarinet is transposing instrument and written a major second higher than sounding. Notation is in treble clef. Bass clarinet in B flat. The bass clarinet in B flat has a sounding range from B flat 1 to B5. Bass clarinet is transposing instrument and written a major ninth higher than sounding. Music for the bass clarinet in B flat is written both in treble clef and bass clef. Bassoon. The sounding range of this instrument is from B flat 1 to F5. The bassoon is a non-transposing instrument, which means is written as sounding. Notation is in bass clef, with tenor clef being used for the higher registers. Notation in treble clef is rare. Contrabassoon. The contrabassoon has a range from B flat 0 to C4. This is transposing instrument and written a perfect octave higher than sounding. Notation is in bass clef, only rarely in tenor clef. All sounds consist of partial tones. For example, when a musical instrument produces a C2, sound vibrates several times and other sounds also appear. The attention of the ear focuses only on the fundamental frequency. But there are also several partials and they all sound at the same time, which you normally don't hear, because these partials are heard as much weaker than fundamental. Eventually, they all vibrate simultaneously and appear to us like single C note. Okay, now we know that each sound has fundamental and partial tones which sound simultaneously. Let me remind you that this ratio of intervals is the same for all tones. The sequence of the intervals is as follows: perfect octave, perfect fifths, perfect fourths, major third, minor third, again minor third, and so on. For clearly explaining, I am stopping at 7th partial, because if write all partials, this series goes on infinity. Let's have a look to all partials of the D minor chord. I want to analyze all low, low, medium, medium, and the high chords in D minor. As we know, the normal hearing frequency range of a healthy young person is about 20 to 20,000 Hz. But best musical range for comfortable hearing is approximate between G3 and G5. In this range, the hearing experience is much greater and you hear overtones more strongly. Therefore, human ear easily could detect all in tune and out of tune sounds in this area. This is one of the reasons why composers write melody in this area. I want to remind once again that this range is approximate. It could be a little bit high or low than this range. Now let's look what happens if we write chords in different range and what we will face. So let's start with low chord. If play D2, it means there are several partials which sounds at the same time with fundamental. The fundamental tone is D2, which we play on the piano. Fundamental tone is also called as first partial. Second partial is D. Third is A. Fourth is D. Fifth is F sharp. Sixth is A. And the seventh is C. For clearly explaining, I'm stopping at seventh partial because if write all partials, this series goes on infinity. Now look at carefully. So we have D and A notes in D minor. Therefore I'm painting them in blue. We haven't F sharp and the C notes in D minor. Therefore I'm painting them in red. If play F2, partials will be arranged as F, C, F, A, C and E flat. We have F and A notes in D minor, but we haven't C and E flat in D minor. When play A2, it means there are also A, C sharp, E and G notes which sound simultaneously. We have A note in D minor, but E, C sharp and the G notes out of tune of the D minor chord. Let's analyze this chord. Conclusion. So, when you play D minor chord in closed path harmony in the low range, you should know that C, C sharp, E flat, E, F sharp and the G notes also will sound, because these partials have a rich sound and more audible. And these partials are in the approximate bass range for human hearing range. Let's move to the next chord and have a look what happens. If play D minor chord between low and medium range, partials are less noticeable, because partials gradually left the bass hearing area of human. Next chord in the middle range. So partials are less audible than previous chord, because they come out in the far away of the hearing. If play D minor chord in the high range, partials are completely inaudible. So C, C sharp, E flat, E, F sharp and the G notes are not risky in sounding. Now you know the partials coming from low chord are more audible. But if move to upper register, partials are less audible. Therefore, it would be better to delete some notes in the low range for reducing C, C sharp, E flat, E, F sharp and the G notes in the D minor chord. The best choice is to write perfect octave in the low range, but it is also possible to write perfect fifths and fourths in the low range depending on the chord. Now is the time to recognize the tone color of each instrument and find the relation between them. This knowledge will come in handy when making different type of textures. It is obvious that each woodwind instrument has own specific tone color. Based on the several orchestration textbooks I have read and my personal observation, it would be better to divide woodwind instruments into three categories: hot, cold, and warm timbres. It is very difficult to define tone quality in words, therefore it would be better to explain it on a simple melody. This is a short excerpt from the C minor prelude for piano by the famous Azerbaijani composer Gara Garayev. Original piano version is in C minor, but for a clear understanding the tone quality of each instrument, I transposed it in a different key. When we start orchestrating the melodies, I will explain the bass range of all instruments. Now just focus on timbres. Melody in the oboe. This instrument has quite nasal quality. It looks like someone talks through his nose. The oboe has a hot tone color, hence I add it into hot timbre category. Melody in the English horn. This instrument is from the oboe family and has the nasal quality as the oboe. The English horn also has a hot timbre, therefore I add it into hot category. Melody in the flute. The flute has mouth pronunciation, like someone is speaking with half-closed mouth and lip. This instrument has a cold timbre when compared to an oboe. Hence, I am adding it into cold category. The piccolo is small type of flute. This instrument has a cold tone color. Melody in B-flat clarinet. The clarinet has mouth pronunciation, like someone is speaking with an open mouth or open lip. Also, this instrument has a cold timbre when compared to an oboe. Hence, I'm adding it into cold category. What about the bass clarinet in B-flat? The bass clarinet is from the clarinet family and has a cold timbre as normal clarinet. I add it into a cold category. Bassoon. There are a lot of ideas about the tone color of this instrument. Rimsky-Korsakov wrote in his Principles of Orchestration book, the four families of wind instruments may be divided into two classes: instruments of nasal quality and dark resonance, oboes and bassoons, also English horn and contrabassoon, and instruments of chest voice quality and bright tone, flutes and clarinets, also piccolo, bass flute, small clarinet, bass clarinet. Samuel Adler wrote in his The Study of Orchestration book, although the bassoon, by virtue of its double reed and conical shape, is related to the oboe. Its tone is less nasal. Some orchestral performers describe their instrument as buzzing and slightly mellow timbre. I agree with all my teachers. Finally, I think we can describe this instrument as follows. This instrument has two kinds of pronunciation at the same time, larynx and nasal. When the players start playing, you first hear the sound of the larynx, a little like a resonant baritone singer. This is dominated mellow timbre, but you can also hear a slight nasal tone color. This instrument is not hot like oboe and not cold like clarinet. Hence, I prefer to add this instrument in the warm category. The second reason, when clarinet and oboe sound in a chord, they sound contrasting. Because clarinet has cold, on the contrary, the oboe has a hot timbre. But if share the chord between bassoon and clarinet, they don't create hot contrasting sound as oboe and clarinet combination. Therefore, the bassoon is best classified in the warm category. The last instrument is contrabassoon. This is very hard to say which is the contrabassoon timbre below the C2, because it sounds more bassy and dark due to slow vibration of tones. But when contrabassoon play above the C2, it sounds like bassoon. Hence, this instrument goes into warm timbres. I want to tell you one more important point. This type of classification, hot, warm, cold, of the instruments are not possible approximately above the C6. Due to the higher and less audible harmonics, all instruments sound slightly similar in tone color. For example, oboe's F6 approximately is the same as flute's F6. They sound a little bit similar. Conclusion. The timbre's difference between two instruments is possible below the C6, which is easy to detect it. ADSR. In our world, every sound has an own sound production time. This is the law of physics. ADSR is an acronym that stands for attack, decay, sustain, release, which shows how sound appears over time. The black line shows the time. When a player starts playing an instrument, the attack refers to the time which sound goes from silent to loudest level. Decay is the time for the initial falling off to the sustain level. In other words, the sound goes from peak to sustain. Sustain is the time during which sound remains at this level. Release is the time it takes sound to move from the sustain to its silent. Release typically begins when a note is let up. Each instrument sound has own ADSR properties, depending on slow or fast attack time, also slow and fast release time. I will explain it on example. To show the exact difference, I choose snare drum and bass drum. The snare drum has a fast attack time in producing, which means that the sound goes to the peak very quickly. Let's listen to it. The bass drum has a slow attack time in producing. which means that the sound goes to the peak very slowly. Let's listen to it. If both instruments are played simultaneously and with the same dynamic, we first hear the snare drum. What about release time? If the player stops striking the snare drum, we get a fast release. On the contrary, bass drum has a slow release time, which means instrument still vibrates after stopped striking. It is the same with the drum set. The snare drum has a fast attack. On the contrary, kick drum has a little bit slow attack. In pop music, in order to match the attack time of both instruments, sound engineers shorten the attack time of the kick drum sound file using various plugins. This makes the beats more energetic. You can ask me, is it important to know? Answer is yes, because ADSR properties also refer to Woodwinds instruments. And this is the one of the main reasons why instruments dominate over the different instrument. For example, oboe and the flute. Oboe has a fast attack time in sound production. On the contrary, flute has a slow attack time. Let's listen. You will understand what I mean. This difference between two instruments makes the problem in balance. To solve these kind of problems, we will utilize another method. That's enough for today's lesson. Let's meet in the next lesson. For the next lecture, we will talk about how to share three-part harmony between woodwind section, which and when instruments dominate over the different instruments, how to get balance in chord voicing, which instruments can change place in chord voicing. Also, after each lecture, students will get home assignments.